Good morning.
Good morning, Professor.
Good morning, Farouz. Good morning, everyone. I wish to maybe give you guys some help when you review. You know that all the quizzes, past quizzes are closed tonight, midnight. I trust you guys have been reviewing for the midterm. And the midterm for my part is almost ready to be available for you tomorrow. So the quizzes, the past quizzes solutions will no longer be available midnight tonight. And but you still have your homeworks and stuff. So if you have any question regarding your homework and the past quizzes, so please bring them on and I'll be happy to answer those questions. Anybody? Any questions? Well, everything we covered up to this point are, are going to be, tested, Okay, of course, I cannot be testing every question from homework, but I select questions from those areas. And the first number one important thing that you will be tested is the mathematical principles. We had some in-depth coverage of the mathematical principles, right? And the meaning, right? The if statements and so on and so forth. And the next one, of course, is truth table. When we were covering, typo, right? Truth tables. Truth tables is something I feel is very, very important for you guys to get familiar with it. The truth table actually is the building blocks of mathematics, and it's also the building blocks, okay, for computer science. Okay, if you guys heard about binary code, right? Have you guys heard about binary code? Binary operations, whatever, right? And that is the operational binary operations is based on truth table. They are basically the same thing, truth table. It's just truth be called 1, false is called a 0, or whichever way you want to set the rule, okay? So the and or relationship is absolutely fundamental for computer science and the development of modern technology. So if someone says math is about numbers, I would disagree. Math is about logic. And what is at the root of the logic is truth table. At the root of the logic is truth table. So when we could randomly talk about and or in our life, but when it comes to mathematics, when it comes to choose the word between and or, I personally, to tell you the truth, I'm very careful when I use these two words. I don't just randomly say this and that and this and that. I would think twice before I put that words when I broadcast these two words. Okay, that's how important, okay, these two words are, the truth tables. Okay, and then and of course we covered, we have some important concepts. Right, so what are these important concepts? The number one is function. Number two, one-to-one function. And then it's increasing function or decreasing function. Okay, and last, of course, is even or odd functions. So these are the important concepts. We've been covering these concepts throughout our lectures, right? We often mention these concepts. We mention their applications. For you, knowing the definition is one thing, but your understanding about the definition as they apply to the mathematical questions in your consideration is very, very important, right? Like I mentioned earlier, students tends to go to the professor asking the professor, what are you going to test us? The professor's answers, the safest answer for that professor to give you is usually, I will test you the basic concept, right? You can try that. You can try that anywhere you go. You go to four-year schools, you go to Harvard, you go to Stanford, Berkeley, Pomona, anywhere you go. If you ask that question, most likely your math professor or your engineering professor will be telling you, I will be testing you the basic concepts. And he or she meant it. He meant every word he or she said. The question is, how much can be derived from the basic concept? Throughout the lectures this semester, I have shown you just from ARD, how much the three concepts of ARD, how much has been derived, right? You have witnessed that. So basic concept, yes, absolutely is essential, but you have to think deeper. You have to think what it infers, right? From that basic concept, what can be derived. So the fundamental concepts, yeah, it's just a handful of them. There are not too many of them. And 6 mathematical principles, right? We talk about 6 mathematical principles. We have studied about 8 weeks, right? 5 courses in 1, 8 weeks. We haven't get to use all of the mathematical principles yet. And we have used some of them. We have used some of them, right? And mathematics, these are the building blocks of mathematics, right? If you say there's anything, you see lots of questions, different questions, but these concepts don't change, okay? And these concepts, as they apply to the question, they don't change. These are the constants, and these are the basics. So not only you need to know what they are, you also need to know how to apply. So that will take you to calculus, to the door of calculus, and that will help you to complete calculus with success. Okay. One of the sad stories could be that you pass pre-calculus. You did the 5 courses in 1, but it take you 3 times to pass the calculus 1. To me, that's very, very sad. That's very, very unfortunate, because when you didn't pass the first time, it already tell you should go back to your algebra classes. You should go back to do the 5 courses in 1. However you do it, that's a different matter. When you didn't pass the second time, that tells you even more, you need to go back to algebra classes, 5 courses in 1. Okay? So it would be so much better if you have a good foundation and then pass the calculus just once, first time. That would be ideal. That would be ideal. From my observation, the students who did not make it or struggling in calculus class, primarily because they are very weak algebraically. So the whole process is a struggle in calculus, because at that time, you not only need to know the basic concept and apply them with adequate algebraic skill, you also have to struggle learning those, probably at least 100 more flashcards of definitions and theorems. Okay, so it's very important for you not only to understand the details of my lecture, right? We say that the devils are in the details. The devils are in the details indeed. Right? Why did I choose to cover those details? Right? That's because those details are fundamental. It's like you're building a house on the rock versus you're building your house on the sand. You guys know the difference, right? So those things we have covered, I hope, okay, will become your rock. And those fundamentals is something we will be testing you on. Okay, we'll be testing on. So the next big item that we spent about 8 weeks on, okay, or 7 weeks, okay, basics 1 table. In basic 1 table, okay, I always try to put this table at the first number 1, and I meant it is number 1. And the perspective as every one of those functions as they're related to these concepts. And it is number 1 indeed. It is number 1 indeed. So this is a number 1, right? Because it introduces some of those very basic rules. That's why we call it basic 1, the basic rules. And the rest of the functions, there are lots of functions you're going to learn, you're going to encounter in calculus. They are just merely, you know, composition of functions from basic 1 table. Okay. So with that said and done, what about basic 1? We have covered every one of those functions in detail. We cover every one of those functions in detail. We graphed them, we plotted the points, we see the devils in the detail, we saw the devils, right? And the domain and range intercepts, these concepts are repetitively presented throughout the classes, especially some of these concepts we have introduced, like one-to-one, increasing, decreasing. So those concepts should not be just dry words to you. They should be alive for you, right? As they are applying to each one of those situations. For example, you will be thinking about, okay, I know one-to-one function. Is the first function on table 1, is it 1-to-1, second, third, fourth? You go through the tables one by one to ask the question, which one of these are 1-to-1? Which one of these are increasing? Which one of these are decreasing? Which one of these is even? Which one of these are odd? And that's what's expected of our students to study, right? So at this point, I also talk about how you can be successful academically, right? As someone who taught mathematics, and as someone also already a student of mathematics for all these years, and these are the experience, and I'm happy to share with you. You cannot limit yourself just knowing the words of definition. You have to also understand what and how it applies to each one of the specific situation. Will your teacher do every one of those details for you? Most likely not, but you are expected to do it yourself. Because if you don't, the consequence if you don't do that, you always feel unprepared for any exam. Okay, so throughout the semester, I also address the method of study, right? You guys have witnessed. We focus on ARD, that's 3 basic concepts, 3 pillars of trigonometry. How much we have derived. We worked on trigonometry, we work on ARD for how many weeks? I think it's approximately 4 weeks, right? We spent the most time on trigonometry. We spent about 2-3 weeks on exponential logarithm. And we spend times on the first 8 functions, which are neither. Focusing on these concepts. So you should not be surprised. Okay, what do we mean by basics? The contents of everything we have covered so far in this course, okay, covered 5 courses in 1. They are basics. Every little point we plotted, those are all basics. Those are all basics, right? Okay. I think I will take your questions. Okay, I shouldn't be talking too much. Okay. How may I help you?
Do you think that you could go over one-to-one function again?
On what? You have any particular example you want to go over?
Just
One-to-one function as a definition. If you want to go over definition. So how do you want me to go over that? In what details?
like how to know, like how to find out a one-to-one.
Whenever you apply the words, whenever one input is not the same as the other, and their respective outputs are different. So whenever the inputs are different, the outputs are different as well. That's the definition. So you're gonna, this is the ultimate criteria. Okay, you will need to learn, you have learned you probably have learned some other tricks before, vertical line test, horizontal line test, right? If you have learned those concepts, visually, you can tell from vertical horizontal line test, if it passes horizontal line test, it's one-to-one, right? But you need to know what is horizontal line test. Horizontal line test means horizontal line is drawn arbitrarily and across the curve no more than once. That makes it a one-to-one function. So to be a one-to-one function, first it has to pass the vertical line test, and then it passes the horizontal line test. That's the visual. However, as you enter calculus, you need to think of these words. You need to think of these words, right? So the visual is no longer sufficient because you need these words to get to the details.
Professor, can you expand on something you just said about, you said, okay, so if it passes the horizontal line test, it's one-to-one, assuming it has already passed the vertical line test, but
Sure.
Isn't the vertical line test the definition of a function? Or do we expand on that in calculus?
Vertical line test is to decide whether it is a function.
Okay, so, okay,
If it is a function, then you start to consider, is it one-to-one? If it is not a function, if it doesn't pass a vertical line test, there's no need to do horizontal line test. It's not a function. If it's not a function, we don't even talk about one-to-one function. You follow me?
okay,
Because
yes,
the premise for function to be one-to-one, it has to be a function first.
okay, I understood correctly then, thank you.
Then when you go through the lectures, right, remember from time to time, we mention these concepts, one-to-one functions, increasing function, decreasing function. We also talk about an increasing function is one-to-one function. And decreasing function is also one-to-one function. And throughout our lectures, you have seen this. For example, when we study e to the power x or 2 to the power x, when we study these functions, right? E to the power x. Right? In all of these lectures, we have been talking about one-to-one functions and so on and so forth, right? Log base 2x, right? ln x, and so on and so forth. So this is a family, and there's another family. In all of these situations, we have addressed these concepts. So in your mind, you'll be thinking, is 2 to the power x one-to-one? then you apply the definition. We do have some shortcut because 2 to the power x is increasing. Increasing function is 1-to-1, right? So we do have some shortcut. Those will be the shortcut, right? You know that e to the power x is increasing. Increasing function is 1-to-1. And so you can apply these results, the study of result, because we do study the relationship between these concepts. Okay, does that help? And further on, as we study sine, cosine, tangent, cotangent, every lecture we mentioned that sine is not 1-to-1, right? So how do we introduce arcsine? Remember those lectures, right? We have been referring to these concepts, how we make function 1-to-1 by truncation, which is a typical method to make 1-to-1 function. And then once the 1-to-1 function is made, we would introduce the inverse function, because 1-to-1 function and inverse function, you have to be you have to be 1-to-1 function in order to have inverse, and inverse is unique. So we've been talking about those concepts throughout, especially the arcsine, arccosine, arctangent, arccotangent sections, right? So those concepts are addressed constantly. That part is called application of concept. Did I make myself understood?
Yes, thank you.
Mm-hmm. So when you watch those lectures, right? Sometimes I might, address something, but they all refer to these two concepts. And these definitions don't change. And you need to think those concepts now in those terms. So horizontal line test is no longer sufficient. You have to understand what is the implication of that horizontal line test, and which this statement is saying that whenever the input are different. So this involves the arbitrary choices of the input and its a consequence. So this has to be satisfied whenever, in order to be qualified for 1-to-1 function. So every word counts. Every word counts in that definition. Next.
Can we do a brief review on the constant E?
Do a brief,
Like,
I'm sorry, what's the question? I didn't hear it.
it's on the constant E. So it's between 2 and 3. It's around 2.7. And could we do a brief review on how that constant is derived?
How that constant is derived?
Yes. Why it's 2.7-ish.
Why is 2.7? You should wait until your calculus class. Your calculus class will teach you how it's being derived. I did not teach how it's derived. Okay, your calculus class will give you a limit form of that. If I do that now, it's I think it's a waste of your time, in terms of preparation for the midterm exam.
Okay, so
then calculus class.
Then for this exam, it sounds like we just need to know it's between.
You need to know between 2 and 3. It's a constant. It's about 2.7. That's all you need to know.
Okay. Thank you.
Next question. Bruce.
Professor, I think for some reason I have in my memory, you probably mentioned whatever we learned this week may not be covered in the midterm, but when I double checked with you this morning, you said, no, it's going to be covered. So we need to update the class in case if getting about the whatever we
Well,
learned this week.
in terms of the actual solving absolute value equation and solving the if statement or inequalities, that will not be covered. But the absolute value function will be covered. Okay, I'll put out an announcement for that. So in terms of how to solve those absolute value equations or inequalities, that will not be covered. But the absolute value function, as we covered in previous weeks, will be covered.
So maybe as an example, basics 4, 5, 6 question 11, 12, 13, 14. You brought it up, which were very good questions regarding absolute value. Those are not going to be candidate to be on the midterm.
I
Similar
cannot say
question.
that absolutely, because you have to understand those examples. Because, for example, the domain and range about absolute value, right? As we apply it, it's indirectly covered. How about I say that?
Good, very good, yes.
You're not going to have exactly the same question as in basic 4, 5, 6, 7. No, you're not going to have those questions. But it's the tool that we use to apply to those questions will be covered, which were covered in earlier weeks of the semester.
Right. As you said, it's basics of absolute value
Right.
function like domain, range, and so on and so forth.
Right. I will not actually pick up questions similar to basic 4, 5, 6 to put them on the exam. No. But you need to understand the concept we covered when we solve those equations and inequalities. Those are covered.
Right.
So how do I separate it? If I tell the student that I'm not going to cover absolute value equation inequality, I don't want student to understand it as, oh, you're not going to cover absolute value concept. No, absolutely. I'm going to cover absolute value concept from the beginning until the end if I give you a final exam. It's a very important concept. But in terms of what we covered this week is solving equations, inequalities involve absolute value. They are, I would say, indirectly covered. Did I make myself clear?
Yes, to me. Thank you.
Domain and range. Any other questions? I know it may sound like a lot of work that you have to go back to study to watch those lectures we have done before, but you must. You must commit yourself to do that from time to time. Okay, this exam, you have 3 attempts. You have 3 attempts. Okay, I'm not making up this in the midterm exam to prevent anything. Okay, I make up that exam is to help you to understand. So the design of this exam is I give you 3 days, 3 attempts. In between the attempts, I expect you to study those lectures over and over again. Okay? Because I know the value of studying those lectures. That's why I do the lecture the way I did. I know the value of it. If you don't believe me, you think, oh, I'm going to have a shortcut. I have all these tricks. That's fine. Maybe you shouldn't have taken my class to start with, right? But those things I covered, those are the bits and pieces. Those are the bricks as you're building your grades. And you will find yourself, you need to use them when you're in calculus 2, calculus 3. I'm not exaggerating, right? If you think you got it, you never touched it, and you're going to tumble somewhere down the road. Because I've seen questions throughout the calculus classes, student ask questions has demonstrated that they did not understand the basic stuff. That's why your professor always tell you, I'm going to test you on the basic stuff. All right. Even though you may not have time to watch all of them, at least you should be watching some of them. Yes, Farouz?
This question is maybe helping the class too, Professor. Like, if I put myself in the shoes of a student and then say 3 attempts. So let's say, for example, I take my first attempt tomorrow morning as soon as it's open, and then you mentioned about 30 questions. Is that 30
About
questions?
35 questions.
35 questions for 1 hour. That would be less than 2 minutes per question. I must be very well prepared. And when I take the first attempt, then I may not, ace it. Then I say, you gave me 2 more attempts. So I'm going to go back, watch the video lectures, homework notes, quizzes, everything, anything. It can help me. Then Saturday morning, I tried the second attempt, right? And if I'm not happy with my result, then Sunday, I'm going to try my third attempt. And then, does that mean you are going to grade my 3 attempts? You are going to put so much time for me, like you are caring about my academic future, like you want me to learn and all those things. Is that how much you are willing to spend time to help me to learn?
Yes, I just want you guys to see these things repetitively. Okay, it's like you play, if you're a musician, you play your melody every day. You do the basic chord every day. Okay, so these are very basic things. I repetitively, I want you guys to do this over and over, watch those basic things over and over until they run in your blood, possibly. That's the only way, let me tell you, that's the only way to be successful in your future courses. Very unfortunately, I have to tell you that. And very fortunately, I have to tell you that. Okay, that's the foundation. Okay, so I allow you 3 times. I hope you use that 3 times. The highest score will be your score, so you have nothing to lose. So by repetitively doing this, you will get better. So I'm hoping through 3 times, you see this 3 times. If you still don't get it, then you shouldn't be taking my class. I certainly have failed you, right? My midterm exam, everybody should ace it. Given the lectures, the way I conducted, and the way I have put on the exams, because those are the knowledge I want you to acquire, no matter how you acquire it, with understanding. Because without understanding, you can't possibly apply them well, right? But if you want to, just to get by, I know there are a million ways to get by. I prepare the exam, I prepare the materials for people who wants to learn. Not for people who just want to get by. Because if you get by this time, you're going to tumble another time. You're going to end up spending 3 semesters to taking one calculus class. And that's not something I want to happen to you. So I know the value of my lecture because I have seen so much. Okay, I have seen so much struggle. I just want to help students from that struggle. It's because they lack the basic stuff. It's 5 courses in one. 5 courses in one. There's no way you can get around it. No politicians and no, philanthropist can get you through that. You just have to put a weight. You have to look in the details. Listen to the lectures. If there's any better way, I don't know. I haven't found it. But the rhythm, the way I taught it, it's a consistency. As I said in the theme of function, right? All of these are functions, input, output. Sometimes you know input, you want to find the output. Sometimes you know the output, you want to find input. That's an if statement. They're all in the same, either the 2 cases. You just have to understand what they are. So that's why I focus so much on meaning, right? Meaning. And yesterday I also mentioned that I'm committed to help you to understand the meaning. And oftentimes, once you understand the meaning, the solutions is staring at you. The answer is staring at you, right? Most of the time, our student didn't do it right because they don't understand what they're doing. 99.99% the chance. If you don't know the question, how could you possibly answer it correctly? Right? So the devils are in the details, indeed. Next question. So one-to-one, is that good about one-to-one functions? Someone just asked, is that Riley?
My question was on E.
E, okay. You think you got it?
Yes.
E, if you want to know more about E, I can give you a little, maybe you will be interested in that stories. Okay, I'm not going to do the calculus stuff for you. E is something related to a finance concept. Okay, so suppose you have certain amount of money. You put it in the bank, right? That's your principal. And you have an annual interest rate, right? Annual interest rate, say R. Okay, and your interest compounded monthly. Okay, and take T years. The question is that if you keep your money, if you let you compounding, right? If compounding, you guys know the concept of compounding, right? You
Yes.
heard of it at least, right? You in your previous course, you probably have heard it. If you don't heard it, you know that you look at your bank statement, you might see that if compounding infinitely times, is that going to make you infinite amount of money?
Yes.
You think so? You think so?
Yes. I think so.
So suppose you have $10,000, you have a $1,000, and you let it compound infinite number of times. So n approaches infinity. So n represents the number of times compounding per year, right? So n represents the number of times compounding. Number of times compounding. Okay, don't worry about the formula. This is the formula, one day when you suppose you just pretend you know this formula, right? N is the number of time compounding. If you allow n compounded infinite number of times, what does that mean, infinite number of times? This is a so-called when you're sleeping, your money is making money for you, right? Every second, every fraction of a second, your money is compounding for you. Do you think you're gonna make infinite amount of money? So your $1,000 you're gonna turn into as much as you want. And you just said yes. Who said yes?
Me, Riley. I think so.
Okay. You think you're gonna have infinite amount of money from $1,000?
Eventually.
Well, you'll be disappointed. You'll be very disappointed.
It's a complicated situation, and we appreciate that you came.
Okay. If you allow that money to compound, the bank will write a program to compound your money. So how much you gonna get?
Less than 300% interest.
Okay. I'm opening a calculus textbook. I'm gonna give you the answer. Compounding interest. If you think your $1,000 can get you infinite amount of money as you wish, you never have to work again, you will be seriously disappointed.
In 1 year, Professor?
It doesn't matter, 1 year, 10 years. Say, give me a year. Give me the number of years you can put that money in the bank. Anybody? Riley, do you have a year?
Well, but wouldn't it would require an infinite number of years to have an infinite?
No, you're not gonna, you're gonna die one day, sorry.
About 50 years.
Okay, so you have $1,000, right? You put it into 50 years. 50 years, so T is 50 years. Right, 50 years. Okay, how much money you think you're gonna get from the $1,000 deposit?
Not infinite.
It's
Not
definitely
infinite.
not gonna be infinite, right? Because I don't want to give you the wrong formula.
Is another formula for
It's
continuous
gonna be e to the power of
RT?
RT,
P times e to the power of RT, is that correct?
correct, 1,000. If you put there for 50 years, right? 50 years, sorry, 50 years. Your $1,000 is gonna turn into whatever rate you choose. Suppose you have, what a rate you have?
This rate is a continuous, Professor, right?
No, the rate is fixed.
5%.
Percent, what is your rate? The key here is you compounding infinite number of times. Okay, so we will let the number of times compounding approaches infinity. Okay, so what rate do you want? Give yourself a favorable rate.
10%.
10%, that's amazing, isn't it? You know that's amazing, right?
Yes.
So R is amazing. You guys, you're pretty good at numbers, Riley. So you have the number compounding infinite number of times. So this number of time compounding, right? So this T is 50, right? This is 10%. 10%, right?
Mhm.
Only thing that's not set is the number of time compounding. Are you gonna get an infinite amount of money? The answer is that quantity has something to do with E.
Sorry.
No, that's not right. Okay, that's not right. So 10%, I'm gonna write 0.1. Okay, so this number. This is how much you're gonna have. So in 50 years, you're gonna have $14,810. You're not gonna have as much as you want.
Is that 148,000?
Yes.
Right now, State Juniper's County and
If you
But not-
allow it to compound as many times as possible. So the number of time compounding approaches infinity. So your bank set up the program to compound your money, right, at a 10% interest rate. A 10% interest rate. Every second, every fraction of second, every nanosecond, they're compounding for you. Even in that case, that's how much you can get. After 50 years, you're not going to have as much as you want. So this is the role of E. So mathematically determined. Okay, so if you really want to know E, this is a calculus concept. In your calculus class, your professor will derive this for you. Okay, so if you want to know anything about E, that's the role of E.
I noticed also if I plug in like 12 instead of, I mean, if I plug in 12 for n,
It's gonna be less than.
it's gonna be less, but it's not like that much less.
Right. So you can plug in 12 if you're compounding every month. If you're compounding 3 every day, 365. You can try all those numbers. Okay, very good. Okay. You can compound every month. You can compound every day. You can compound, twice every day. Right?
Every second.
Every second, right? How many seconds do you have?
That's why we go to E continuously.
Yes,
For-
that's the idea of compounding, right? You're compounding, you divide divide seconds into nanoseconds. You're compounding. That's what the limit tells you. You're only going to maximize your deposit, your money up to 14,000 and 148,000. That is a lot of money from 1,000. I don't disagree with you, but it's not as much as you want, right? And how do we get that? That's the role of E. Okay, the story of E. This is one story of E in finance. Which you're going to see how it's been derived in calculus. Does that satisfy your curiosity?
It does. Thank you.
You'll be looking forward to calculus, right?
I am actually.
Good, good. I actually like your question. It's just I don't want to do calculus stuff too much in pre-calculus, right? Everybody else is trying to review for a midterm exam and to get by this course. But that will be irrelevant. That will be relevant to every one of us, right? Every one of us need to have some kind of, we have some access to money because we need it to live, right? Any other questions? Compounding infinitely.
Could we review how to find like the inverse of a one-to-one function?
To find the inverse for one-to-one function, first you have to determine this is a one-to-one, right? You already know this is find inverse for a one-to-one function. Right? The basic step is step 1, step 2. Step 1, you have, y equals to something, y equals f of x, right? So your first step will be swapping x, y. We have talked extensively about what is the implication of swapping. Right? So you have turned this into, this will become x, that becomes y. And then you solve for y. So this is how you do it. Do you have any specific examples? This is how you do it. These swaps, we've done these swaps for what? For exponential logarithm. We've done the swap for sine, arc sine, after truncated sine and get arc sine. We've done those, right? One by one. So those are the examples you can refer to. And do you have other examples you want me to work with? So these are the general steps, right? We have, when we were doing the truncation of sine, truncation of cosine, truncation of tangent, truncation of cotangent, right? After the truncation and we swap the x, y, we have seen those points being plotted, input, output swapped, right? Domain range swapped. Those are the implications. And the graph, right? The swap caused what? Caused the graph to be symmetrical with respect to that line y equals to x, right? So that's the serious domino effect of that swap. Does that make sense? So any other questions related to this? You have anything you want me to solve?
Oh, no, thank you.
Mm-hmm. So you can see the general theme, just on one-to-one, we have applied to it many, many times, right? Exponential to log, log to exponential. Farouz.
Professor, in this regard, you made an example of trigonometric functions, how we can get the inverse of them. How about rational functions? For example, f of x equals 2 plus x over 3, for example, rational function, right?
Sure, if you have, say, y equals what?
2 plus x over 3. All over 3, all over.
All over 3.
Yes, rational function, yes.
This is a rational function.
Yes.
How do we find its inverse? Is this one-to-one? That's the first question you ask. 2 plus x over 3. This is the function you're talking about, right?
Yes.
This is a line. This is not a, well, this is a rational function for sure, but this is a linear function, right?
Yes, I just used the example, but you can have better examples if you choose to. For rational function, finding the inverse of a rational function.
Okay, so this is also an inverse, a rational function, but it happened to be a polynomial as well. So you can apply these steps, right? Since you gave this example, I would just first do this, and I can give you another example if you want. So step 1, so I have this function, right? So I have this function, so I would write it as y equals to 2 plus x over 3. Right? Step 1, swap. The consequence of swap, and this y turn into x, x turn to y. This function, as a linear function, the domain and range are the same. Okay, domain is all real numbers. The range is all real numbers. You guys see that? You can quickly graph this, right? This is elementary algebra. This is a line equation. The range and domain are the same, right? If you quickly graph this, that's what you see. It's a straight line. You guys see that? So this is a line. So if you look at the box, the horizontal, right? Horizontal domain, all real numbers extend in both directions indefinitely. Vertically, the range, it goes indefinitely, right? So the domain is from negative infinity to positive infinity. So when we swap, it doesn't make much of difference because domain and range are the same. When you swap, they're still the same, even though there is a swap happening. Step 2, this is also why that when you were first introduced inverse function, right? Most of the well, this concept was first introduced probably in elementary algebra, intermediate algebra. Well, that's before we put 5 courses in one. And people, the professor probably didn't mention these swaps of domain and range because they're the same. That's why they just put it on the side. But it should be mentioned. But if whatever, right? It's just there's so many aspects to cover. So sometimes the teacher may not have covered that. Okay. But anyway, so once we've done the swap, right? What do? We solve for y. We solve for y from where? Solve for y from where? From the consequence of swap, right? So you're gonna solve it. So how do you solve it? You're solving for y. So you're gonna multiply 3 on both sides. And then on this side, you have 2 plus y, right? And y is isolated by subtracting 2 on both sides. So that's the inverse function. So your function f, so this is f. This is your f, right? And your f inverse, this is your f inverse. (3x minus 2). Domain range is swapped. Domain range is swapped. But the domain range are the same. So when you swap them, no difference. Makes no difference.
You mentioned another example with a different domain and range. We could choose a quadratic function, for example, simple function.
Well, quadratic function is not a one-to-one. Quadratic function is not a one-to-one. The example we have done is logarithm function that's one-to-one, right? So suppose you have f of x, right? 2 to the power x, right? That domain is all real numbers. And the range, it's all positive numbers. All positive numbers, okay? Or you say 2 to the power x is larger than 0 in one sentence, right? So when you follow these steps, right? When we follow these steps, so now f of x is 2 to the power x, right? So when we swap, y equals to 2 to the power x now is swapped to 2 to the power y. And then you solve for y. right? Solve for y from here. And what do you get? By definition, y is equals to log base 2x. And domain range swapped. Domain range swapped. Okay, so this swap happens at the time of swapping. In our classes, we have done these points. We did the points, didn't we? We did
Yes.
the points. So one's domain is the other's range. So this is domain for the new function, for the y function here. Okay, so I will probably just put it here. Domain, range, right there. But the actual swapping is already taking place at this step. And the points all swapped. Every point on one is swapped to the other graph. Remember we did these graphs? 2 to the power x. The graph. Okay. That's 2 to the power x. And over here you have, let me put say maybe 9. Right, so that's domain range, you see that, right? That's 2 to the power x. And its inverse make it red. It's inverse, right? I can make it just a little bit wider. Right? That's inverse to each other. In terms of swapping, we saw these swapping taking place, right? When x swapping with y, when x is swapping with y, and we have done this for truncated sine, arc sine, truncated cosine, arc cosine, truncated tangent, arc cotangent. They're all follow the same pattern. Okay, so 2 to the power x log base 2x. If you look at the points, right? This is 0, 1 and swapped. That's a swapping 0, 1. And over here is 1, 0. You guys see that swap? That's the effect of swap. Okay. Another point over here. Another point over here. Right? This point is 1, 2. And this point over here, the star is 2, 1. And what do they correspond to? What do they correspond to? This guy corresponds to e raised 2 to the power of 0 equals to 1. The input is 0, output is 1. That's 0, 1. 1, 0, 1, 0, 1, 0. That's log base 2 of 1 is equals to 0. Input is 1, output is 0. Do you guys see that? These are two different functions. You can keep going. We did that in class, didn't we? That's the effect of swap. And we continue to do that for e to the power x, ln x. You should not be surprised. You're going to be tested on these things, you guys. What are the devils in details? These are the devils in the details. If you don't understand this, you're going to be in trouble. Right? And the truncated sign, arc sign. Remember, I gave you guys those homeworks, didn't I? Homework. Did you do it? If you don't do it, you're lost. Look at that. All these homework being assigned to you. You think they're not going to show up on your exams? You'll be disappointed. You'll be disappointed if you think they're not going to show up on your exam. I test you what I taught. I test you what I believe is important for you. So there's no surprises, no surprises, no surprises on my exam. Why do I want to surprise my student? No point, right? I want you to be successful and you want to be successful. Why do I want to surprise you? From the quizzes you see, all the quizzes I give you, right? Any one of them is a surprise? Any one of them is outside the lecture or outside the homework? So why should this midterm exam should be any different? I want you guys to repetitively practice, get to the details to get it. Is there any other way? I don't know. I don't know any other way. I wish I do. If you found another way, let me know. Right? Right? All these homeworks we have assigned you. Right? You think these are not important? I spent all that time after class, in class, we make these tables. We spend hours and hours there. And I'm not testing them? I must be crazy. Right? If I don't test you, that's a problem. Of course, I will not test you every details, but I will select something to test you. All right. So my goal of teaching this class is for understanding. If you want to understand, you take my class. If you don't want to understand, you have a super duper memory, go somewhere else. I can't teach you. You're too smart for me. Right? Because I already told you how dumb I was, right? At the beginning of the semester. Why do you think I told you that story? It took me 4 times past the driving test. That person cannot be super smart, right? All right, do you get it? All these are devils in the details. Okay, and similar thing for E. Okay, I mentioned how important E to the power X and ln X are. We cover those sections. You should not be surprised they're going to be on the exam. Right? You should not be surprised. Anything I spend time on extensively. Most likely they're going to show up on your exam. Next question. Is this enough about one-to-one function? right? We've been doing this throughout, right? And for E, right? For E, the details, right? E. And I also have done the comparisons, right? E, 2 to the power x, 3 to the power x, 10 to the power x, e to the power x, the relative positions. We have done that. Right? There's relative positions and there are inverse functions in relative position. We've done those, right? And if you think those are not important, what else could be important? You teach me, right? I teach you everything I think is important for you. Otherwise, I think I'm not doing my job. I'm wasting your time. Everything that I personally have struggled and I think need time to cover. I teach from my conscience. Next question. Do we need to elaborate some more on this? You should go back to watch those lectures, okay? We have 20 minutes left. Bring your questions. When you watch my recording, you should have paper pencil with you, just like you are attending a class. Pause the replay as needed. Pause replay as needed because the lecture sometimes is long. You can't watch it just by, let it play. Sometimes you need a break, okay? Paper, pencil, write it down, replay, forward, rewind, and all of those functions can be used at your disposal. Next question. Do not be afraid. Any question is a good question.
My question is that if it has a bracket, like the domain and range, then that means it's inclusive. And if it has like the parentheses, it's exclusive.
Correct.
And what is that supposed to mean?
Okay. If X belongs to an interval like that, okay, I'm just taking an example. 1, 3. What it means is it means that X cannot be 1. But X can be any number as close as close as possible to 1. Larger than 1. Okay, it cannot be less than 1, right? Because this means X is larger than 1, smaller than or equal to 3. That's what it means. So X can be 1.00000001 but it just cannot be 1 exactly. On this side, it can be 3. X can be 3. X can be 3. Oops. X can be 3. Okay? In other words, X can be any number between 1 and 3, not including 1, not including 1, but include 3. Is that clear? Is that clear?
Yeah.
Next question.
Professor, do we have typo, but include 2 or 3?
Oh, include 3, sorry. Right, so if you draw a number line, right? That's a 3. 3 here, I will put a dot. 1, I put a circle, meaning it cannot be 1. Okay, so the number of the choices of a number for X, it can be anything between 1 and 3, including 3, but not including 1. So you can get close as possible to 1 from larger than 1, but you should never assume the value of 1 exactly. Does that make sense? So that's what it means. You can be infinitely close to 1, larger than 1, but never is 1. So you can get close as possible, okay? So this kind of thing can only be in our imagination. No computer can simulate it. No computer can simulate it properly. The concept as close as possible, I think only human can imagine that. We're human are capable of a lot of stuff, right? One of them is imagination. And this is one of those imagination situations that we have. You're going to see that imagination play out in calculus over and over again. Next question.
Can you
5
go
classes
over-
in 1 indeed. I'm sorry. Yeah, go ahead.
I was gonna say, can you go over some of the trig 7a examples, like sine parentheses arc sine 3/2?
Sure. Trick 7a. Which one?
Sine parentheses arc sine 3/2.
Is number 9?
Yeah.
Can we solicit an answer from the audience?
I will be the last.
Okay, thank you. Please wait.
Isn't the answer undefined?
Why?
Because 3/2 is outside the domain of arcsine.
Perfect answer. Perfect answer. When you see the input is 3/2 and you look at the function applied to it. Okay, and that function has a domain and range. Arcsine has a domain and range. What's the domain and range? Arcsine. Anything outside the domain will be called undefined. So the domain for sine is between -1 to +1. The range okay, so all these were in the lectures. Okay, the range, I give you multiple forms. One of them is this. Right? There's another form. Okay, you go back to the lecture, you will see it. To answer this question, you will say 3/2 is outside the domain of arcsine. So you can safely say, then you say arcsine. You can even remove that, okay? It's undefined. What is the importance of domain and range? Domain tells you what can be the input, and the range tell you what to be expected as output. Very important. You're going to be using domain and range on daily basis. I would say on hourly basis. Every single day, you're taking calculus classes. Next question.
Professor, I must admit that was a very good question, and also that was a very good answer.
Thank you. So you not only need to know the answer, you also need to understand why. Very good. Thank you, Farouz. I didn't give you the opportunity to answer the question.
You're welcome.
Sorry about that. We have 7 minutes left, but
No,
I can go over for you. Okay, no problem.
No. I just want to remind the students, based on 35 questions and only 1 hour, how fast we must be able to answer question as Elijah represented, right? The answer. And that goes by practice, doing the homework, everything you have said so far, 8 weeks, right?
Mhm.
And then Math Study Center, I'm available today from 3 to 6, tomorrow from 10 to 4.
Yeah. Thank you, Farouz. I'm glad to report to you that Farouz will continue to be your TA, your tutor, while I'm on leave. At least that's what I asked the dean to do. Okay, and I think he agreed. That's not a problem. So you're gonna have a new teacher, okay, from Wednesday next week.
Do we know it's he or she?
I actually don't know. I don't know yet. The department has sent out announcement, but I didn't see it. They probably passed me by.
Thank you for confirming me staying as a TA, I mean, in-class tutor until end of semester.
Of course, I
Thank-
appreciate your hard work. And
Yeah.
and it's going to be entirely the dean's decision, but trust me, the dean will make that decision for the best interest of students. And he's also constrained about the availability of instructors and the school policies. But I'm available. I'm still available. I'll be here on Monday and Tuesday. So bring your question, please. You see about those 22 functions on basic one table. Domain and range are listed as the top questions for all of them. So I hope you understand the importance of those, do you? Right? And the process we went through, right? So that's why I hope you guys go back to watch the lectures, unless you can find other sources. I'm not saying my lecture are the only source of knowledge, certainly not. There are other sources like textbook. If you're a good reader, you will have read these things. But these days in time, I don't think people actually read a mathematical textbook. I don't know about you. I think most people don't read mathematical textbook. And people people like to listen, like to watch, right? So the way we can communicate has changed. So if you want to watch, you want to, practice while watching, so you can watch my recordings because I closely cover those materials. But if you have other sources, you can watch a Harvard professor giving lectures or Stanford professor doing these sort of things, and go for it. I'm not jealous, right? Anyway, every way you learn, well, Khan Academy, right? Some people like Khan Academy, no problem, no problem. Anything and everything that works for you to help you become successful, go for it. But understanding is the key. For understanding, I teach. Next question, please. You see, 7A is a concentrated place that you're going to see. You're going to need a domain and range for all those functions, all the trig functions: sine, cosine, tangent, cotangent, arcsine, arctangent, arc, cotangent, and so on and so forth. That's a concentrated place that you constantly has to, and of course, applying ARD and apply domain and range constantly. Okay, so you focus on domain range, ARD, DRA, you will be invincible. You will be invincible. It's all about that. It's all about that. Okay, so once again, domain tells you what number can be qualified for input, and the range tell you what to expect.
Professor, can we
Yes.
use another example which answer is not undefined? Maybe we can.
Sure. Maybe Farouz can choose one for us.
I don't have access to the trick 7a right now.
No, you don't?
You revealed my hands.
You don't have that file?
I have to go and open another window.
Oh,
but,
okay, never mind. So how about the rest of the class? You want to choose some questions from 7A for me? So by the time we do 7A, we already have a lot of tools, right? ARD, DRA, domain range. And on top of that, we also have the table on the top of 7A, right? Those nice properties, but some of them are conditional. A lot of them are conditional, right? For example, if you take number 24, for example, right? I'm just picking up some questions randomly. Arc cosine of negative 5 pi over 6. There are more than one way to do it. Right? If I do it the ARD, you certainly can do the ARD's way, right? You're gonna measure angle from clockwise. You have a terminal in the third quadrant, and you have a red number, you have a blue number, and you can just pick up the red number. Okay, so that way you're gonna get what? You're gonna get a negative √3 over 2, I believe. Yes, guys? Right? And then arc cosine, right? For arc cosine, well, cosine is defined on all real numbers, so there's no domain issue, no problem. So you get negative √3 over 2 from cosine negative 5 pi over 6. And then what? Well, this ratio is between -1 to +1, right? So if you are think out loud, you know that negative √3 over 2 is in the domain. It's in the domain. And the range, right? So the answer you expect before you get to it, the answer you expect is going to be between 0 and the pi. Okay, so in particular, this answer is going to be 5 pi over 6 DRA. Another way to do this, just to show you there are more than one way to roam, right? Cosine negative 5 pi over 6 is the same as cosine 5 pi over 6, because the cosine is an even function. Cosine is even function, right? What is even function? Do you guys know what even function is? Opposite input, same output, right? And then from here, you can apply one of the properties, right? You can apply one of the properties on the second row. There's a property here. Okay, you can still go there. But it would just get you, you know, arc cosine of cosine x is equals to x if well, what? if x is between 0 to pi. Remember we plotted those points, right? We plot the points for the truncated cosine and the arc cosine. We plotted point by point doing that. Do you think we do that for nothing? I hope not. Okay, so this apply because this x is in the place of 5 pi over 6. So the answer is going to be just 5 pi over 6. Okay, so you can use ARD to do it. And the next one is DRA. Right, so in this direction is ARD. From A to R to D. And that way is from D to A. Do you have any other questions? Our time is up, but if you have questions, I will stay for you.
I say thank you very much, Professor, and have a nice weekend. That
Not
is
a
me.
Thanks,
problem.
Professor.
Of course, anytime. Any questions? I'll stay for you if you need more time.
Thanks for the recap lecture, Professor.
Of course, anytime. Thank you. Thank you, everyone. If you have any questions, don't hesitate to reach out to me, okay? We have Pronto inbox and all of that stuff. Don't hesitate to reach out to me. And of course, I cannot tell you the answers on the exam, but I can answer your other questions related to it. Depends on how you ask the question, okay? Depends on how you ask the question. Okay, so I'll see you guys on Monday. The best of luck.